Welcome to another data science deep dive on a technical track for Data Science Along YouTube channel. In the following presentation, Kim Martin, data science manager at Netflix, will discuss some interesting business problems and applications of data science based on her experience working with multiple companies in streaming media domain. I hope you enjoy her talk.
Greetings, everyone. My name is Kim Martin. I'm the manager of platform data science and engineering at Netflix. And today I'm going to be speaking about interesting applications of data science for infrastructure in the streaming world. The disclaimer I'll give is that although I've worked at Netflix, YouTube, Bandpage, and HBO, I won't be talking about specifics of their infrastructure, but each of the problems that I describe exist due to the nature of them being streaming businesses. So these business problems and applications are generalized over problems most companies face when dealing with streaming media. And with regard to where I've worked and where they are on their journey, most are solved at various degrees of completion. So the problem with infrastructure in the streaming world is that there's a lack of investment in data science within streaming media infrastructure. So many organizations overlook the dire need and don't invest in proper data science within their infrastructure. This oversight can lead to inflated infrastructure costs, poor developer experience, mystique about the foundation of the business, and the complexity of the streaming infrastructure exacerbates those deficiencies and could reduce a business's growth potential unnecessarily, or worse, it could bankrupt the business. So as the user base for streaming media grows, the infrastructure scales needs to grow to support new product features, user-driven event traffic, the storage of product interactions. And so the image of fairness in this picture is somewhat equal in terms of opposing forces, but it's pretty inaccurate. It's gonna feel more like this, where the users get joy from the product, they continue to get joy while the infrastructure struggles to keep up. So why does this happen? Laypersons are able to understand the product because they're a user and can see the impact of data science or data-driven intelligence in the product, but call infrastructure a black box or magic they don't need to understand in order to use the product. Inside companies, we don't do the hard work to tie the infrastructure impact and costs to the high-level business metrics, yet if the network went down, the business would go down, and they'd probably lose money. So it seems important. There are household terms where people use products like Amazon and Netflix and Google search, and they understand that there are things called recommendation engines and ranking algorithms, and that impacts what they see in those products. But they fail to make the mental jump to see how those same techniques could be used to improve the underlying infrastructure that powers those same products. So common understanding of data science becomes restricted by the front face of the products. As a hiring manager, I've seen for years data science professionals who still don't see the opportunities in the infrastructure for the same techniques and methodologies they use for user-facing products. One of the interview questions I ask is about opportunities to improve the infrastructure with data and try to gauge how much a candidate has even thought about the breadth of application of the algorithms and methodologies they know so well. Typically, it doesn't go well. They kind of falter a little bit and lean into the product itself when the infrastructure is what I'm asking about. So it's an interesting experiment. So why is streaming a unique problem? To recap some of what I've already said, but to put it in perspective, streaming is uniquely difficult. There are lots of moving pieces, lots of real-time events to consider. The volume and velocity of data seems to be higher, and the infrastructure relies a lot on availability and resilience to be actually baked in. It's difficult because users are unpredictable, behaviors and trends are unpredictable, and all of that has an impact on the diversity of the data that streams through a streaming service. So take any streaming service that has a viral hit, like YouTube has Bieber, which I think everything he does becomes viral. Netflix had Tiger King. I don't remember what Apple had recently, but they've had some pretty viral hits there. But with little data, you end up overspending on scale. So there's always going to be a need for cloud nimbleness in order to account for the unknown or the unexpected. And data science plays a big part in that nimbleness. From one angle, you'll want to understand what it means to be viral, or at least have the ability to detect the virality as it begins. And then from another angle, you want to be efficient in your scaling in both directions during the viral event and post the viral event. And I don't want to skip over the fact that users have high expectations of streaming media. They expect it to be available when they want it, smooth when they consume it, and they walk away or unsubscribe when it's not. So there's a lot of user sentiment that drives their adoption of your streaming media. And there's already a lot of research into poor video quality being a cause for churn with users of streaming platforms. Same is likely true for audio quality, but I couldn't find a great graph that would have been descriptive enough. So I'll leave it to you guys to follow up on that if you don't believe me. But beyond video quality is the whole user experience, and that experience is deeply rooted in the stability and quality of the infrastructure. Yet businesses tend to not bubble up that infrastructure impact to meet the other business metrics and treat it like a somewhat ubiquitous black box that just works and isn't really part of the business problem, and they couldn't be more wrong. So what do we need to do? We need to start to, or continue to, evangelize data science in the infrastructure. Convince businesses to invest heavily in infrastructure data science via metrics and success stories if influence alone won't work. And sometimes this means bringing infrastructure engineers into the fold and creating evangelists out of them too. So this is a short list of a number of data science opportunities within a streaming company's infrastructure layer. Predictive analysis on network compute and storage demand, bottleneck analysis within the infrastructure, smart schedulers for big data jobs, error categorization for faster and easier debugging, job classifiers and prioritization, trend analysis on resource utilization, optimize real-time logging and data collection. And then there's even more. Storage location and access optimization, usage patterns to inform default settings and allow for auto-tuning, forecasting to scale compute resources, change experimentation and regressions, optimize routes between apps and jobs across networks, optimize user traffic routes across networks, clustering of running apps for job and cloud nimbleness, and even more. Network anomaly detection for security and other unexpected events. Correlation and causation analysis between tools and platforms within the same infra stack. Cache optimization. Graph analysis on interconnected services. Request trace and lineage analysis and optimization. And this is actually a short list. Like, the opportunities for data science within the infrastructure layer is nearly limitless, depending on what you want to optimize for. Some of those options being cost optimization or speed or reliability or predictability or ease of use. So understanding your business needs helps to hone in on which opportunities best suit your infrastructure at different parts of its evolution. But there's always work to be done. So infra data science is never a solved problem as long as the business is growing. So I'll move into a few ideas about how to apply data science in the infrastructure. And these are, again, meant to be generalizations. These types of problems exist in all streaming media companies and some in non-streaming media companies. But thinking about these problems and the scale of the products and the applications that power them alone, we'd be able to easily recognize that we need to move away from heuristics and into something that can learn. Heuristics only get you so far. In a growing streaming environment, there's no real way to understand all of the users or actors whose data or machines interact with the platform. So heuristics actually become a maintenance burden since they usually work until they don't. So leaning into some more machine learning type algorithms can go a long way. Even simple techniques can sometimes show significant gains over manual rules. So the idea of error classification, when I think about this, I think about the problem being that errors happen in software, period, full stop. They happen often when software products are heavily used. They happen in different patterns due to the different reasons. In most organizations that don't invest in data science in the infrastructure layer, most of these errors get manually triaged, then debugged by software owners. But that's a tedious process, and we know there are better solutions than that. So while errors are split out by custom software, or that are spit out by custom software can vary greatly, the actual response to errors is usually a relatively small set of actions that become somewhat in a class of multiple errors. So if we can better classify the many distinct errors, we can likely boost developer productivity within an organization by cutting down triage time, and in some cases, we can abstract away some of the manual steps of developers and have that software handle the error without even ever involving a human. So how do we do that? I'll admit that there are a number of ways to skin a cat, anything from tight rules engine and heuristics, all the way to complex ML algorithms are on the table to improve this process beyond the human intervention. Sometimes simplicity works, period. Like that, no one should shy away from the simple solution just because it's not the hammer that you hold. So I'll walk through an idea that I find interesting, but I actually haven't seen implemented at any place that I've worked, but I would love to. I'll walk through an idea that I find interesting about how we can approach the problem of error classification with none other than my hammer reinforcement learning. There are lots of methods for dealing with error classification. I like to think about error classification as a reinforcement learning problem because as the product and the feature evolves, the class of errors grows, although slowly, or can be addressed more granularly and provide better classification and more accurate response from the product or from people. This is a simple reinforcement learning agent for doing error classification. So how do we do that? In this diagram, the environment is the infrastructure or part of the infra that you care about. Maybe it's the network load balancer, maybe it's the compute resource allocator, maybe it's an application platform of some sort. For this example, let's just say you're working with app developers and the environment is an application platform of some sort. Working with this approach presumes that your actions are finite and your state is observable. Your agent lives in this environment and eventually gets into a state where there's an error. Once that initial error state is observed, the agent chooses an action to try with the goal being to resolve that error. So the next observed state will either have the error resolved or it won't. And once that observation is made about the action taken for the state, we can apply a reward to be positive if it moved into the new observable state where the error is resolved, or negative if it remains in an error state. So you use the state action pair to help the agent learn how to behave when that state is observed again in the future. And there's much more complexity to it than what I'm describing here, but since my examples are meant to be generic, I'll refrain from writing a reward function or policy to guide the state action choice for the Markov decision process. But this example should illustrate how something that seems so common as errors in software could benefit from some data science in order to create automation opportunities for platforms that strive to become intelligent enough to recover from common errors and actually provide a good developer experience. Smart schedulers address the problem of resource contention in multi-tenant systems. So lots of times contention leads to workload failures at runtime, which require manual intervention, including like restarts or retries, or maybe there's even some tuning on retries, but there's usually some manual intervention. And smart schedulers come into play when you've reached the point where the number of workloads is high enough and the business utilization is diverse enough that you can't find an easy way to set prioritization and orchestrate the jobs manually, or your scale is large enough that cost is becoming a concern, or your platform is just too hard to use because of rejected or ejected jobs or preempted jobs or something like that. So there are more compelling reasons to use or create smart schedulers, but these few I've mentioned should likely be sufficient to convince you that there might be a there there. So how do we do this? It sounds simple, right? Like just schedule jobs and go about your business. But again, there are many ways to approach this issue with making schedulers smarter. Some simple ways exist, including rule-based systems where you annotate all your workloads so much that you can easily decide how to prioritize during orchestration. But there are some other ways that are more flexible and allow for you to create efficiency gains without ever knowing every intimate detail of your workload. And for those familiar with schedulers and resource orchestrators, I want to make sure that I'm being clear that I'm not talking about things like Yarn in Hadoop or Kubernetes or Mesos, for instance. I'm more so talking about something custom within your organization that actually allows you to decide what to submit to a resource negotiator. And with that tuning and what tuning parameters or additional metadata, because that scheduler will understand the current platform capacity, and it will understand business context type things about the workloads to be run in order to make really good decisions about what to submit and when. So the execution orchestration will still need to happen at the resource level, but the layer above can be smarter than either a cron job run or a user pushes submit and something happens, or some other trigger submits a workload. So you now have the power to change the contention for resources and add a non-artificial element of prioritization within the set of workloads available to be run. So presume that everything is in queue and you're making decisions about which workloads to add to the platform utilizing the platform's resources and capacity. And presume everyone has prioritized their workload to be the highest priority, right? So priority really doesn't matter if it's manually set. So how do you decide what to run? This can definitely be seen as an operations research problem. The scheduler problem or job scheduler or assignment problem, whatever you want to call it, there are many names for the same sort of constraints analysis. So in this example of smart schedulers, you're trying to fit a number of jobs into a finite number of nodes such that you minimize the idle time or white space in the graph of the worker nodes, but you only put the jobs that can fit within the constraints of the cluster of nodes on at a time. So I'm using the word node as a placeholder for whatever your unit of compute resource is. But this is tricky because sometimes there will be jobs that require so many resources, so many nodes, that you'll have to potentially create idle time on the nodes in order to even free up enough resources to run those jobs. But you can use any variety of operations research approaches in the realm of schedulers and usually produce something much more efficient than a manual rules table or user-made prioritization queues. So I also want to talk a little bit about the idea of the infrastructure as a black box and why it's a barrier of entry for data science work in businesses. So when people don't understand things, they tend not to want to invest in them, even if those investments could improve the business's overall goals. So it's important to be able to articulate the need for data science within the infrastructure to business stakeholders. At some point, they understood that they needed computers to scale their business. At some point, they understood that they needed an internet connection to stream the content. So at some point, they will understand how data plays a major role in the things listed here. Hiring inefficiencies, like you may be hiring for skills that would become unnecessary with a little bit of data and some more automation. Another major draw for business stakeholders in applying data science to the infra space is the ability to wrangle in the cost of actually scaling the infrastructure. Assuming that more users of a product means more scale of data resources, being able to optimize for that scale is critical to controlling the potential cost of the business to operate. And there are real innovation pain points that come from both these types of hiring inefficiencies and cost inefficiencies. Think about things like the inability to expand the business by adding a new feature or a new business line because it's cost prohibitive. Or think about a barrier of entry for using the infra due to the complexity or lack of automation or simplification caused by lack of data help. Or even a very real thing of reaching your infra capacity and not being able to scale rapidly, or having to pare down existing innovation, or not understanding what the potential outcomes are of remaining at that scale. All of that is bad. But moving from a black box or a mystique aura about the infrastructure and into a more enlightened era of data science and infra can help propel a company into the future. Without it, they run the risk of being left behind. So what else? There are so many opportunities for good statistics, machine learning, operations research, and data modeling applications in the infrastructure that getting over the initial hump of identifying what opportunities exist and moving into the application of these methodologies is likely the key to a streaming business's success. My hope is that anyone attending this talk looking for inspiration about how to contribute to data science in the infra space leaves knowing how valuable this work really is and how impactful even small changes can be toward the success and viability of a streaming company. If you heard about a problem here that you didn't think about before, try something new. Create your own success story. I'm really passionate about the infrastructure space, and with streaming, you tend to feel like you're the only one in the world solving these types of problems at this scale. And while you may not be the only one, in reality, you're probably one of a few. And it's exhilarating and challenging and all of the things data scientists look for in a problem. So welcome to the jungle. Thank you.
That was Kim Martin, Data Science Manager at Netflix, sharing interesting applications of data science infrastructures in the streaming world. If you like to watch more videos like this, you could subscribe to the DS Insider program where you could see our complete on-demand video repository. You can subscribe following the link in the video description below. Have a great day.